This practice final utilizes parallel arrays. It is imperative that you understand the relationship between parallel arrays and how to process the related data. It is also important that you understand functions, how data is passed to functions through arguments, and how a value can be returned by a function. This practice final is very similar to the programming final. So it is to your advantage to complete this programming assignment and completely understand it. Let's look at the practice final description. You were awarded a part-time job for the English department at ASU. They have asked you and another programmer to develop software that will store information about students and create miscellaneous reports from the data. Your coworker has written the main function. She defined parallel arrays to hold the data that is being acquired. She populated the arrays in her main function. I am going to first explain the arrays, what each of them holds, and the relationship between them. The array student name holds the names of 8 students. The next array, student ID, holds the ID for each of the 8 students. And the age array holds the age for each of the students. The two-dimensional array student grade holds 10 grades for each of the students. Let's look at the relationship between these arrays. James Ray Wood has an ID of 709345578 and is 25 years old. He has earned an 88, 98, 78, 92, etc. for his grades. Notice that James Ray Wood's information is at index 0 in each of the one-dimensional arrays, and in the student grade two-dimensional array, James Ray Wood's grades are at the row index of 0. So the data in these arrays is related by the index or subscript in the array. Likewise, Wade Brent Hughes has an ID of 39543993, is 55 years old, and has earned a 97, 67, 88, 35, 99, etc. for his grades. In a two-dimensional array, the first index refers to the row and the second index refers to the column. So student grade sub 00 holds an 88, student grade sub 04 holds a 99, student grade sub 35 holds an 89, and student grade sub 72 holds an 82. It is best to process arrays using for loops and two-dimensional arrays using nested for loops. This example code shows how the outside loop iterates through each row, and for every row, the inside loop iterates through all of the columns. So this set of nested for loops is processing the student grade array in row order. There are also 2 more parallel arrays used in this program. The information array holds the string which describes the column information in the two-dimensional array. The array stuInfo holds the information about each student. Each row corresponds to a student, and each column corresponds to the specified information. Column 0 determines if the student is a transfer student. Column 1 determines if the student is on scholarship. Column 2 determines if the student is classified at risk, and so on. The stuInfo two-dimensional array is a Boolean array, so each value can only be a 0 or a 1. So, specifically looking at the data in the arrays, recall that James Ray Wood is at index 0 in the student name array. In the stuInfo array, his data appears on row 0. We know that he is a transfer student and is on scholarship based on the relationship between the arrays because there are 1s in columns 0 and 1. Recall that Wade Brent Hughes has an index of 3. He does not fit any of the informational descriptors because there are zeros throughout row 3. Now let's talk about the functions that you need to write to process the data in the arrays. The first function is called compute average. Now, compute average needs to compute an average for any given student. So you're going to accept as arguments the two-dimensional array of grades, the index of the student of which an average should be computed for, and the number of grades. So looking at our two-dimensional array of grades, recall that each row corresponds to a student and each column corresponds to a specific exam. So for a given student, and this is going to be the parameter defined as int student, this is going to determine which student we need to compute an average for. And when that is passed in, your program needs to use a loop to traverse through every single column for that student. Now, remember that the number of columns is the number of grades. So we have this third parameter here defined as num grades, which will determine how many times our loop needs to iterate so that we can process all of the grades for the given student. Now, at each iteration of our for loop, what we need to be doing is adding to an accumulator the grade. So when our for loop completes, we will have in our accumulator the sum of all of the grades for the given student. When we fall out of the loop, we can easily compute the average because we can take that accumulator value, which is the total of all the grades, and divide it by the number of grades. Remember that third parameter is the number of grades. So what this function needs to return is the average that you compute. Let's look at the second function that you are responsible for writing. This function is called highest score on exam. Now, the purpose of this function is to find the highest exam score for some specified exam. So highest score on exam will accept as arguments the two-dimensional array of grades, the index of the exam on which we want to find the highest score, and the number of students. So this is going to be the number of rows. So let's take a look once again at our student grade array. This is our two-dimensional array of grades. Each row corresponds to a student and each column corresponds to a specific exam grade. So this function will be accepting as its second argument some specified exam. This is the exam that you need to find the highest score of. So your function needs to use a loop to traverse through each row for some specified column, which is specified by exam index. And at each iteration of your loop, you're going to be looking for the highest exam grade. When this loop terminates, you should have stored in a variable the highest grade that you found. This is the value that you need to return, and it corresponds to the highest grade for the specified exam. Now let's take a look at the third function you need to write. The name of this function is index of highest. The purpose of this function is to find the index of the highest score for a specified exam. We know that we have parallel arrays, so when we determine the row index of the highest exam score, what we can use that index for is to determine who made the highest exam score. So our index of highest accepts as arguments our two-dimensional array of grades, the index of an exam, so this is the specified exam, and then last, the total number of students. You will once again use a loop to traverse through the grade array, And at each iteration of the loop, you're looking for a higher grade or a higher score. Now, when you find a higher score, you need to record that higher score in a variable, and you need to also save the index of where you found that score. This is going to be the counter in your loop. When your function terminates, you will return the index of the row on which you found the highest score. Let's take a look at our last function. It is called percent in age range with spec. Now, the purpose of this function is to compute the percentage of students that qualify for one of those specified information properties that are in some given age range. So, for example, we might need to find all students that are in the age range of 18 to 20 who are on scholarship. This function accepts as arguments the age array, the two-dimensional array of student info, the number of students, the lower and upper age range that we want to use to search for the specified information, and the index of that specified information. So what we need to do in the body of this function is to use a loop to traverse through the age array and determine if the age falls inclusively between that lower and upper parameter value. And if so, we need to increment a counter that we can use to keep track of the total number of students that fall in the age range. Okay, next we need to check the info array for a 1 at the specified info index. Now, if a 1 is found, we need to increment a counter that we're using to keep track of that specified information. So we need two counters here. One to keep up with all the students that fall in the specified age range, and the second counter to keep up with all the students that qualify for the specified information. Now, this function needs to return a percentage in decimal format of the number of students who fall in the specified category in the given age range. Your function can calculate this percentage by dividing your informational counter by all of those who fell in the age range counter. Recall from our previous example that we were looking at all students in the age range of 18 to 20 who were on scholarship. For this example, we have lower in our function parameter list being initialized to 18, upper is initialized to 20, and then the parameter info index is initialized to 1. Recall that the information array and the stu info array are parallel arrays. So looking at the information array, column 1 refers to students who are on scholarship. In this specific example, your function's age counter should be a 3, and your function's info counter should be a 1. This is because we are checking for a 1 in rows 1, 6, and 7, because these rows correspond to the students who are in the age range of 18 to 20. When your loop terminates, the decimal average for this example should be 1 divided by 3, which is 0.33. Let's look at the rest of the instructions for the programming assignment. You should not modify the main method in any way. So all output statements required for this program have been included in the main method. The functions are already called from the main method. So all of the tasks that you have to complete need to be written in the body of the functions. I've included the function prototypes and the function headers. And the program actually compiles as it is written in the template window, because I've included dummy return statements in the bodies of the functions. So before making any modifications, go ahead and run this program in develop mode. That way you can see what is being output prior to any modifications that you make on your own. Now you need to make sure that you follow the recommended programming convention. So make good use of white space, document your code, which I've already included a lot of documentation for you above the function headers. And you need to make sure that you use self-documenting variable names. Okay, in order to receive credit for this exam, you must copy-paste from your Zybook the signature of your work, the latest submission timestamp, and the total score earned into the body of the Blackboard essay question. Let's now go take a look at the programming template window. I have included for you the entire main function, the prototypes for your functions, as well as the function headers. Now, before we start looking at it in more detail, I want to show you line 10 here. It defines global constants that are utilized by not only the main function, but also in the prototypes and the headers. This is because when you are using two-dimensional arrays as function parameters, you must define the number of columns. So therefore, numGrades is needed here in the prototype, and numInfo is needed here in this part of the prototype for percent in age with spec. So we had to define these outside the main function as global constants. Now, when these specifications need to change down the road, this program will still run. If we need to modify the number of students from 8 to say 20, all we have to do is change this constant and this program will run perfectly fine. Likewise, if we need to compute 20 grades, all we have to do is come in and change this constant to 20. Okay, so before I look at this code in detail, I want to go ahead and show you that it runs as is. I've already pasted the sample code from figure 1 in my input window. I'm in develop mode. I'm going to run my program, and I want to show you that I do get some program output. This first table is output in its entirety. You don't have to change that. This is outputting the information that was read into each of the arrays. This second table is almost complete, but the only thing missing is the average of all the grades for each of the students. Now, I call your function that is called compute average. So compute average will return the average for each student's grades. Now, the next table is not complete because it needs the output from two of your functions. This column of information right here, highest score, will be populated by the function highest score on exam. So I've called highest score on exam. You have to return the highest score on the exam for exam 1. So this correlates to column 1 in the student grade array. This is column 2 on the student grade array. This is column 3, and so on. Now, the person who scored the highest, well, this is actually going to be determined by the function called index of highest. Remember, index of highest returns the index of where the highest grade was found. So this is the row index. And then because we have parallel arrays, we can use that same index as the index into our student name array. And that's how we're going to output who scored the highest grade. And then last, this table is populated by the function called percent in age range with spec. I've written the code to pass in the age ranges into your parameters, lower and upper, and then each of these are determined by the column. Remember, transfer student was column 0, on scholarship was column 1, and so on. I'm going to be calling this same function percent in age range with spec over and over and call it with different arguments. For example, to compute this percentage, I will be passing into your function the lower age range of 0, the upper age range of 17, and the index of 0 so that your function can return the percentage of students in the age range of 0 to 17 that are transfer students. Now let's go up and look at the actual code in the coding window. I've defined all of the variables and arrays for you in the main method. In fact, you do not want to change anything in this main method. It's completely functional. This part of your main method reads in all of that data that I provided in figure 1, and this part of the code outputs that first table. Remember I said that first table was output in its entirety. You don't have to change anything here. It's correct. Now this second loop of output creates a table, and everything in this is correct except your function here needs to return the correct value in order to have the average for the student output by this statement. So if you can write compute average to return the correct average, then you'll get the correct output here. Now this next loop outputs a table, and remember that table had for every single exam the highest score on the exam and who made the highest score on the exam. Well, your program has to actually compute the highest score on the exam and who made the highest score on the exam. So if your program actually outputs that information correctly, then this table will have the right output in it when this output statement in line 106 runs. Okay, last we need to output another table that has all of the information regarding the percentage of students that are transfer students, on scholarship, at risk, in campus housing, and are athletes. Now I've written everything for you to get that table output correctly. All you have to do is make sure that your percent and age range with spec function runs correctly. Notice that it is called multiple times. It's called here, and then it's called here, and so on. So in this example right here that I have highlighted, we are calling the function, and the lower age range is 0, the upper age range is 17, and I here is the index that we are using in our loop. This I in the loop ranges from 0 to 4 because there are 5 total informational indices, and so they start out at 0. And remember, 0 was transfer student, 1 was on scholarship, 2 meant at risk, and so on. So this code creates that last table, and as long as you return the right information from your function, the table will be correct. Now I'm going to take you down to the actual functions, and notice that I've created for you documentation, the function header, and a dummy return statement. This is true for each of the functions. So they work as is, they just don't produce the right output. You need to write the body of the functions so that each of them will return the right value. In order to earn points on this assignment, you will get 2 points for outputting your tables with the correct information. Remember, I formatted your tables for you. All you have to do is make sure your functions return the right values in the right format. So in other words, this average here in this output, well, that is the value that your function compute average returns. This output here is the value that your function highest score on exam returns. And the person who scored the highest exam is determined by the function index of highest. Remember, index of highest finds where in that two-dimensional array which row the highest score was on. So remember, we also have parallel arrays, so once you find the correct row, you can use that same index into your student name array to figure out who made the highest score. And then this last bit of information, This last table is populated by your percent and age range with spec function. There are also some unit tests defined. In fact, there's one unit test for each of the functions. So this makes sure that your functions return the correct value. Don't forget that when you are finished, you need to copy and paste your results into your Blackboard test question. You can do that by going to submit mode, submitting for grading, and then taking your mouse, highlighting your signature of work, your latest submission time, and your total score by right-click, copy, or Control-C will work as well, and then pasting into the Blackboard test question window your signature of work, your latest submission time, and then your score. Once you have all of that submitted, then you can click Save and Submit. So I'm going to let you take it from here. Remember that I said earlier, this assignment is very much like the final. So write these functions and it will help prepare you for the final programming exam. So good luck. If you have questions, of course, let me know, and I will do my best to help you.